The processes unfolding in deep space are not distant events. They shape the air we breathe, the seasons we live through, and the very survival of life on Earth. Our planet is not a static home. It is a dynamic system, constantly responding to forces from beyond its atmosphere. Solar flares, cosmic rays, galactic cycles, and to its own violent internal rhythms. Tectonic shifts, volcanic eruptions, and the slow dance of ice sheets over millennia. One of the most dramatic transformations Earth has endured is the Ice Age. A global cooling so profound that continents became frozen wastelands, sea levels dropped hundreds of meters, and entire ecosystems vanished overnight. These were not minor winters. They were planetary resets. And history shows us they don't come once. They return again and again. So what triggers them? And could one be coming again sooner than we think? For millions of years, Earth has cycled between warm interglacial periods and brutal glacial epochs. During the last major ice age, known as the last glacial maximum, about 20,000 years ago, massive ice sheets stretched from Canada down to New York, from Scandinavia across Europe to Siberia. 2/3 of Earth's land surface was buried under kilometers of ice. Sea levels fell by 120 meters, exposing land bridges between continents. Asia connected to North America across the Bering Strait. Australia joined New Guinea. England became part of mainland Europe. Human populations survived in refuges, caves, valleys, coastal strips, hunting mammoths, gathering lichens, enduring winters where temperatures plunged below -40 degrees Celsius. Yet despite the cold, this was not an era of extinction. It was an era of adaptation. And in some ways, it was the crucible in which modern human civilization began to form. The most immediate driver of global cooling isn't the sun. It's not the wind. It's not even the tilt of Earth's axis. It's volcanoes. When a supervolcano erupts, like Yellowstone or Toba 74,000 years ago, it doesn't just spew lava. It blasts into the stratosphere billions of tons of ash, sulfur dioxide, and fine particulate dust. This material doesn't fall quickly. It spreads globally, carried by high-altitude winds. Within weeks, a haze forms around the planet, blocking sunlight. Not all of it, but enough. A 1% reduction in solar radiation reaching the surface can trigger a decade-long winter. Sulfur dioxide reacts with water vapor to form sulfate aerosols, tiny reflective particles that scatter incoming sunlight back into space. This is the opposite of the greenhouse effect. It's the anti-greenhouse. The cooling begins not at the poles, but at the equator. Temperatures drop. Rainfall patterns collapse. Crops fail. Forests die. And then, snow doesn't melt. It accumulates. Year after year. Ice grows. Reflects more light. Cools more. A runaway feedback loop begins. And if the eruptions keep coming for decades, even centuries, the ice sheets start to spread. And once they do, they become self-sustaining. Massive, silent, unstoppable. While Earth's interior stirs, the sun watches. And sometimes it sleeps. In the 17th century, from 1645 to 1715, astronomers observed almost no sunspots, no solar flares, no prominences, just a dark, quiet disk. This period became known as the Maunder Minimum, named after the English astronomer Edward Maunder, who first documented it. During those 70 years, Europe suffered what scientists now call the Little Ice Age. Rivers froze solid. The Thames in London hosted frost fairs. People skated on ice, sold food, played games. Vineyards in France disappeared. Grain harvests failed. Famine swept across the continent. Even Greenland's Norse colonies vanished. buried under snow and silence. Ice cores from Antarctica and Greenland show a sharp drop in solar activity during these times. Carbon, 14, and beryllium, 10 isotopes trapped in ice layers, confirm reduced cosmic ray shielding, meaning fewer solar storms meant weaker magnetic fields, allowing more cosmic radiation to reach Earth, altering cloud formation and further cooling the climate. The sun didn't stop shining, but it dimmed, and Earth paid the price. But here's the deepest mystery. Why do ice ages happen every 100,000 years? Why not every 20,000 or 50,000? The answer may lie not in our solar system, but in our galaxy. Scientists have found a startling correlation. Major ice ages coincide with the solar system's passage through dense spiral arms of the Milky Way. Every 100 million years, we pass through regions thick with interstellar dust and gas. As we move through these zones, cosmic rays intensify. More high-energy particles strike Earth's atmosphere. More clouds form. More sunlight is reflected. The planet cools. Some models suggest that when our solar system enters a galactic arm, the increased radiation triggers long-term climate instability. The ice ages aren't random. They're rhythmic, like a heartbeat. And we are currently approaching the next phase of this cycle. The last major glaciation ended 11,700 years ago. We've been in interglacial, a warm pause, ever since. But natural cycles suggest we're overdue. Not by centuries, by millennia. And nature doesn't wait. It sounds impossible, but during the last ice age, Earth was actually more habitable for humans than it is today. The vast exposed continental shelves, now drowned beneath oceans, became fertile plains. The Amazon basin was drier, split into savannas. The Sahara was green. Deserts shrank. Oceans were colder, richer in nutrients. Fish thrived. Large mammals roamed freely. Humans migrated farther, faster, and with greater success. Art flourished. Tools improved. Language evolved. Agriculture began, not because people were clever, but because the land gave them more to work with. The cold forced innovation. The ice carved valleys that later became rivers. The glaciers ground rock into fine silt, creating the richest soils on Earth. Today's breadbaskets, Ukraine, Kansas, the Pampas, were formed by ancient ice. Without the last ice age, there would be no wheat, no rice, no cities, no civilization. Cold didn't destroy humanity. It shaped it. If another ice age begins, how fast will it come? Not overnight, not in your lifetime, but within centuries. First, the cold snaps grow longer. Winters don't end. Snow stays. Permafrost expands. Forests turn to tundra. Agricultural zones shift south. Food production collapses in the northern hemisphere. Major cities, New York, Moscow, Beijing, face energy crises. Power grid strain. Ports freeze. Shipping routes vanish. Migration becomes inevitable. Millions flee toward the equator. Wars over resources ignite. Governments collapse. Economies fracture. But life adapts. Animals migrate. Plants evolve. Microbes survive in ice. Humans build underground habitats. Greenhouses powered by geothermal heat. Nuclear fusion reactors buried deep in bedrock. Water is extracted from glaciers. Air is filtered from permafrost gases. Society doesn't vanish. It transforms. It becomes quieter, slower, more resilient, less dependent on global trade, more connected to local cycles. The future won't be dystopian. It will be different, and perhaps wiser. We've been told that carbon dioxide causes warming, and it does, but it also prevents cooling. In the past, when CO2 levels dropped below 280 parts per million, ice sheets grew. When they rose above 300 ppm, ice melted. Today, we've pushed CO2 to 420 ppm, higher than any time in the last 3 million years. So why worry about cooling? Because the natural cycle is still running. Human emissions have delayed the next ice age, maybe for tens of thousands of years. But delaying doesn't erase. It only postpones. And when the cycle finally resumes, the rebound will be catastrophic. The ice will come back, not slowly, not gently, but violently, with a force that overwhelms our infrastructure, our technology, our illusions of control. We may have bought ourselves time, but we haven't changed the rules. The planet still breathes in ice, and someday it will exhale it again. There are signs, subtle, quiet, almost invisible. The Atlantic meridional overturning circulation, the ocean current that brings warmth to Europe, is slowing. The Arctic is warming 3 times faster than the rest of the planet. Glaciers in Greenland and Antarctica are melting faster than predicted. But paradoxically, freshwater from melting ice is disrupting saltwater flow, weakening the currents that carry heat northward. Some scientists warn this could trigger regional cooling in Europe and North America, even as the planet overall warms. Could this be the first ripple of a new ice age? Not yet, but it's a warning sign, like a fever before a storm. We don't know if it's a fluke or the beginning of a pattern, but we're watching, and we're unprepared. Earth doesn't care about our politics, our economies, our smartphones, our wars, our climate treaties. It moves on its own rhythm, driven by the sun, the stars, the rocks beneath our feet, and the silent pulse of galactic time. Ice ages are not disasters. They're transitions. They're the planet resetting its balance. And we, fragile, brilliant, short-lived, are merely guests in this ancient cycle. We may delay the next ice age with carbon emissions. We may build domes on Mars to escape it, but we cannot stop it forever. Nature always wins. The question isn't whether another ice age will come. It's whether we will be ready. Will we be the generation that panicked? Or the one that prepared? The one that fled? Or the one that adapted? The ice doesn't hate us. It doesn't love us. It simply returns. And when it does, we will either rise with it or be buried beneath it. We hope this journey ignited your curiosity. Stay with us as we explore the quiet forces that shape Earth's destiny. Subscribe and join us for the next discovery.